Bismillahirrahmanirrahim, C2, week 5, and lesson 2. The topic for this lesson is focusing or accommodation. Objectives. By the end of the lesson, you will be able to define the term accommodation, explain focusing on a near object and focusing on a distant object. Describe the two common defects of the eye and how these two common defects can be corrected. So the question is, how do we see things around us? We all know that when light falls on an object, the rays of light, they are reflected from the object, and some of these reflected rays, they fall on the eye. The light rays are refracted through the cornea and the aqueous humor onto the lens. Lens causes further refraction and the rays converge to a focus on the retina. Let me explain it through a diagram. So you can see the object. The light rays, they get reflected from the object and they enter the eye. As soon as they enter the eye, they get refracted. They are bent by the cornea, the aqueous humor. They enter through the pupil and they are further refracted by the lens and focus onto the retina. Refraction is also done by the vitreous humor. So an upside image is formed on the retina. A sharp image is focused on the retina. So image formed on the retina is inverted, both laterally and upside down. It's smaller than the actual size of the object. This image on the retina, it stimulates either rods or cones depending on the intensity of light. We have already discussed in our previous week lesson, the rods, they function in dim light and cones, they function in bright light. So the nerve impulse generated, it's relayed to the visual area of the brain via the optic nerve. The messages are interpreted by the brain and the person becomes aware of the object the right way up and the right size. Light rays reflected from the object, refracted by the cornea, by the aqueous humor, enter through the pupil, refracted by the lens, by the vitreous humor. Upside small image is formed on the retina. The message is taken via optic nerve to the brain and brain corrects the image the right way. Focusing. What is focusing? Focusing or accommodation is adjustment of the lens. Why this adjustment of lens is done? So that a clear image of the object that is at different distance, it can be formed on the retina. Sometimes you have to focus on a near object, like you want to read a book. So you have to focus that is a book that is near to you. Sometimes you have to focus on an airplane that is flying past away from you. So the lens, it makes adjustment according to the objects that are placed, that are near to you, that are far from you. So in focusing, thickness or curvature of the lens is adjusted. And this change in the thickness and curvature of the lens, it allows the light rays to get focused sharply on the retina. Let's see what happens when you have to focus on a distant object. When you have to focus on a distant object, the accommodation for far vision occurs. So the light rays, they are reflecting off a distant object. They are almost parallel to each other when they reach the eye. So these parallel light rays, they are refracted through the cornea, aqueous humor into the pupil. So these changes, they occur in the eye when you have to focus on a distant object. The ciliary muscles in the ciliary body, they get relaxed, pull the suspensory ligaments. As a result, the suspensory ligaments, they become taut and pulling on the edges of the lens. You know that the lens is being held by these suspensory ligaments, and these suspensory ligaments, they are controlled by the ciliary muscles in the ciliary body. So ciliary muscles, they relax, pulling on the suspensory ligaments. They become taut, pulling the edges of the lens. As a result, lens becomes thinner and less convex. So its focal length is increased, and light rays from the distant objects are sharply focused on retina, stimulating the photoreceptors. So as photoreceptors are stimulated, an impulse is generated. This nerve impulse is transmitted via optic nerve to the brain, and brain interprets in order for the individual to see the distant object. So I repeat, for the distant object, the ciliary muscles, they relax, pull on the suspensory ligaments. Suspensory ligaments become taut, pull the lens, lens become thinner, less convex, thin, less refractive, and its focal length is increased, and light rays, they are sharply focused on the retina. You can see the ciliary muscles, they relax, and the suspensory ligaments, they become taut, and lens becomes flatter and while focusing on a distant object. Focusing on a near object. So when you have to focus on a near object, so accommodation for near vision occurs. So in this case, the light rays, they are diverging. They are not parallel. These diverging light rays, they reflect off a near object. When reach the eye, they are refracted through the cornea, through the aqueous humor, enter through the pupil, and these changes, they occur. The ciliary muscles, now they contract. They relax their pull on the suspensory ligaments. The ligaments now become slackened and they relax the pull on the lens. Lens is elastic in nature, so it becomes thicker now and more convex, more refractive. So its focal length is decreased. Light rays, they are sharply focused on the retina, stimulating the photoreceptors. Impulse is generated that is transmitted via optic nerve to the brain, and brain interprets in order for the individual to see the near object. So ciliary muscles, they contract, suspensory ligaments relax, and lens become thicker and more convex. It's rounder and focusing on the near object. Okay, so when you have to focus on near object, ciliary muscles contract, suspensory ligaments slacken, muscle tension is low, and lens becomes thicker. It becomes thinner when you have to focus on a distant object due to due to relaxing ciliary muscles and stretched suspensory ligaments. Okay. The two common defects of the eye that you come across in your and how they can be overcome. So the two common defects of the eye are myopia, short-sightedness, and hyperopia, the long-sightedness. In both the cases, the light rays, they do not focus on retina. Either they focus in front of the retina or they focus behind the retina, so a clear image is not formed. And these two defects, they are treated with spectacle lenses which refract the light rays, so they do focus on retina. So someone with short sight, they can see near objects clearly. Short sight, it means they can focus clearly on the near objects, but they cannot focus on the distant objects. So short sight may be caused either your eyeball being elongated, so that distance between lens and retina is too great, lens being too thick and curved, so light is focused in front of retina. So this can be corrected by placing a concave lens. When the concave lens is placed in front of the eye, the light rays are focused sharply on the retina instead in front of the retina. People with long sight, they can see the distant objects clearly, the far objects clearly, but they cannot focus properly on near objects. Maybe the eyeball being too short and the distance between the lens and retina is too small. There may be maybe a loss of elasticity in the lens, so it becomes either thick, so it's thick enough to focus. This may be age related. In the older people, they may lose the elasticity in the lens, and the lens becomes thicker enough to focus. So as a result, lens focus light behind the retina instead of onto it. You can see the light rays, they focus behind the retina. This can be corrected by placing a convex lens, and while placing a convex lens, the image is sharply focused onto the retina. There is a message for you. Every closed eye is not sleeping and every open eye is not seeing. So you need to take good care of your eyes. Thank you so much. See you in the next week with a new lesson. Allah Hafiz.